we are going to continue with statistics. Very simple subject. Okay, where the most enjoyable thing is there are only two exercises. Only one exercise for statistics and then one exercise for probability. Okay.
Yeah.
Very easy subject, this one. Okay. But only if you learn this, you can learn the other one, regression analysis and all that.
Yeah. Okay.
Next chapter we'll do that. Then we'll do what you call we're supposed to be very heavyweight subject, but we'll make it very interesting. I think that is the last chapter that you have. Production management, operations management. Okay, we'll do operations management. So that way we'll have finished 3 of the last 3. Then we'll come to financial mathematics and let us see what will happen. Okay. Now, yesterday we stopped at what is the harmonic mean and where it can be used. Wherever there are rates, like, kilometers per hour or kilometers per liter, a bird is making noise or you are making noise.
Bird.
Bird is making noise. Okay.
Yeah. Unmute then if that's disturbing.
Yeah, it's very, that bird is disturbing us, but nice sound otherwise. Okay, whenever you need to open up, you can unmute yourself, no problem. So we saw that 20 kilometers by 5 hours is 4 kilometers per hour. Then you can have 1/4 hour per kilometer inverse also. So that is the way of understanding that harmonic mean can be used. Where is harmonic mean used? Usually harmonic mean is used wherever there are rates like kilometers per hour or kilometers per liter, or what else you can say. There are many examples. I will just show you some. Periods per semester, number of periods per semester, or tons per month. Okay, how many tons Heterogenuity was exported per month, or how many tons was imported per month. Okay, that case. So periods, number of periods per semester. So this kind of rate situation, you should consider harmonic mean than arithmetic mean. Okay, so that is important. Okay, now what we did. Okay, automobile driver example. Okay, example. Automobile driver travels from the plains to the hill station at 100 kilometers distance at average speed of 30 kilometers per hour. He then makes a return trip at average speed of 20 kilometers per hour. Okay, what is his average speed over the entire distance? 200 kilometers. Now, here, usually what people take, they take average, means they take arithmetic mean. Okay, that means they add up the 30 kilometers per hour and then the 20 kilometers per hour. How they do it? Can you see? So 30 plus 20 divided by 2 will give you 25 kilometers per hour. So that is average speed. Okay, but that is not going to give you the correct average here. Okay, so you should not, now that you are a mathematician or a statistician, you should not use that arithmetic mean in order to calculate the average. Okay, you should immediately understand that here there is number of kilometers per hour. So that means harmonic mean is the more appropriate one. So then you use harmonic mean, what will happen? Harmonic mean. So n is 2. Okay, meaning there are 2 ways he's going. First fellow is going at first journey is making at 1 by 30. Second journey is making at 1 by 20. See, geometric means what? 1 by x1 plus 1 by x2 plus 1 by xn, n divided by that. No, like that you have to do. So now you are getting 20 and 30. They are taking 60 as average. So here you get 3, here you get 2. That means 5 by 60. Okay, 5 by 60. So 2 divided by 5 into 60, 120 by 5. Okay, 120 by 5 is equal to 24. See, if you take arithmetic mean, you are getting average is 25 kilometers. But If you take geometric mean, it is, harmonic mean, it is lesser. It is 24 kilometers per hour, which is more accurate. Okay, so that is the difference between arithmetic mean and geometric mean. So depending on the situation, you have to use this situation. You have to use geometric mean only, not arithmetic mean. Harmonic mean only, not arithmetic mean. So HM, that is what you have taken. Now, see, there is a relationship between the averages. Between what? Between AM, arithmetic mean, GM, okay, where you do log of x, sigma x divided by n, and then do anti-log, and then harmonic mean, where you just do n by 1 by x, sigma 1 by x. Okay. If it is going to be frequency based, then sigma f by x. If it is going to be what, class range, continuous values. Continuous values, 10 is to 20, 20 is to 30, and then you are given frequency, what you will do? N by sigma f of m, midpoint will be taken. That's all. So these are three formulas. First formula is straightforward formula, sigma n by 1 by x, sigma 1 by x. Okay, n by sigma 1 by x. This is a straightforward direct formula. This is the frequency with discrete distribution formula. This is the frequency with continuous distribution formula. Okay, this is formula number 3. This is formula number 2. This is formula number 1. Okay, there are only 3 ways you can do it. Okay, so either there is discrete point data without frequency, or there is discrete point data with frequency, or there is continuous data where you have to take the midpoint and substitute that for the value of x. Okay, you are understanding that? That is there coming right from 9th standard. So no big deal, new thing. It's not a new thing. Now, what is the relationship between the 3 things? Arithmetic mean is always slightly greater than geometric mean, and geometric mean is always slightly greater than harmonic mean. Okay, now let us see that with an example. Let us see that with an example. Is giving one example. Here you are getting x and frequency. Okay, that means it is discrete frequency data. So first you put the 2 columns of x and x and f. Okay, so x value 7, 10, 13, 16, 19, 22, 25, 28. That you put, all that you put here. Okay, then frequency of the corresponding frequencies, all of that you put here. Okay, so far data is given. Okay, now you have to find out both arithmetic mean, geometric mean, and harmonic mean. Okay, harmonic mean is sigma f divided by x, n by. So you have to find sigma f of x. That's why you have this column. Okay, then anti-log of sigma log of f into log of x, okay, by n. That is the formula for geometric mean. So that is why you are having this formula, this column f of log of x, okay, and you are having the column f of log. This both is for geometric mean. You have this. Okay, for harmonic mean you are calculating this column. For arithmetic mean you are calculating this column, arithmetic mean, normal mean. Okay, what is normal mean? Sigma f of x by n. That's all. Arithmetic mean is very simple. Now, sigma f of x by n. Okay. So now you are calculating 7 into 10, f into x 70. Then 10 into 22, 220. 13 into 24, 312. Like that you are getting all these values. Okay. 25 into 12, 300, all that. Then you find the sigma f of x, sigma fx. Okay, now what is arithmetic mean? Arithmetic mean is nothing but 2357 divided by 140. Okay, 2357 divided by 140. Let us see how much that is. 2357 to get 2357 divided by 140 equal to 16.83. Okay, so this is the first one. Arithmetic mean is equal to 16.8, say 4. Okay, we are rounding it off. 835 is equal to 834, 884. So this is arithmetic mean you have found out very easily. Now you find log of x. Okay, log of x is how to find out log of x. You use the log table. I have a log thing with me, or in your final pages of the book. Let us go and find out from the final pages of your book. Do you have the book with you? Logarithmic tables. Offline.
Not right now, uncle.
You have a book with you for log tables. Okay. X is 7. What is log of x? What is log of
Uncle, I
7?
don't have the book right now.
Huh?
I don't have the book right now, uncle.
Oh, you don't have the book right now. Okay. I will tell you then the values. Log of 7 is
Yeah.
0.8451.
Log of X.
0.8451. Okay.
Okay.
So correct. This is correct. This is what they are given is correct. Okay. Log of 10 is 1. No need to find out. Then log of 13. See, the problem is they are giving only up to log of 9.9. Okay. Now, how you will find the other log? You have to do something else. That's why better you use calculator. Only log up to 9.9 is given. Then anti-log is also given only up to 0.99. Okay. So better to use, not to use the tables in your book, better to use the calculator. So anyway, they are given values now. 113, log of 13 is 1.131. Log of 16 is 1.201. All of that they are given. Now, what you have to do, f into log of x. F into log of x. And you arrive here. Okay. F into log of, because what is the formula? Formula is anti-log of sigma f log of x divided by n. Okay. The whole anti-log. Okay. That is what is the formula. N will be capital N. N is equal to sigma f. Okay. So sigma f you already know. N is equal to 140. Okay. So whatever you find divided by 140. Log of x and f log of x, all this is coming. Okay. 10 into 8.84, 8.45. 22 into 1, 22. 24 into 1, like that you are getting this answer. Now, once you get this answer, you sum up all this. You are summing up all this, you are getting 167.209. So 167.209 divided by 140, and then find the anti-log. Okay, 167.209 divided by 140. How to find? Let us use the calculator. 167.
Uncle, the answer is 11.9928.
Okay, you got the answer, huh? Divided by 140.
Oh, wait. I think it's the wrong answer.
1.194. Huh? Okay, very
Yeah.
good. Screen sharing went off. Okay. 1.194 divided by 140. No. This is 1.194. Now you have to find anti-log of 1.194. Okay. Now I have the app which will find the anti-log. From that app, I can give you anti-log of 1.194.
Uncle, can you send me the app on WhatsApp?
I'll send you.
Okay, uncle.
It's
Thanks.
just called log and anti-log app. That's all.
Okay.
Okay. See, like this it is.
Yeah, okay.
That's all this app. You put the value, it will give you anti-log below. Now what I'm going to put? Value is 1.194. 194. Okay, I put like this. Now I'll press that red button to give me the value.
Okay.
It's giving value. See, 15 point something.
I can see, uncle. Yeah.
15 point. That is
631. Yeah.
15.63. 15.63. So this is geometric mean. Now you have to find harmonic mean. Harmonic mean by is f by x. So f by x, 10 divided by 7 is 1.413. Then 22 divided by this 22 divided by 10. Okay, 2.2. 24 divided by 13, 1.8 was it. Like that. 28 divided by 16, 1.75. Then 19 divided by 19 is equal to 1. Like that. 9 divided by 22.4. Okay, you got all that. Now you have to sum up all this, sigma of all of that, sigma of f of x. Okay, that is all there is to that game. Okay, once you get that, divide n means 140 divided by 9.6852. Okay, let us calculate that. 140 divided by, do you have calculator? You can also calculate. 140 divided by
Yeah, uncle. I'm calculating.
9.6852. What are you getting?
1 minute, uncle.
14.46. See,
Yeah.
GM you are getting 15.63. That is greater than 14.46, which is harmonic mean. What was the original mean we found? I forgot that. Okay, no problem. You can, anyway, they have worked out this problem. 16.84. So you find that 16.84 is the arithmetic mean, which is greater than geometric mean, which is 15.63, which is greater than harmonic mean, which is 14.46. Okay, very simple. All of these things, if you get a sum like this, compare the arithmetic mean with geometric mean and harmonic mean, take it up and do it. It will take some time, but you will get full marks because it's a very straightforward sum. Very straightforward sum to do. So arithmetic mean greater than geometry mean greater than harmonic mean is true. Okay. See, harmonic mean is a measure of central tendency for data expressed as rates like kilometers per hour, kilometers per liter, periods per semester, tons per month. Like that, whenever the rates are coming, you should think maybe I should use harmonic mean and don't use arithmetic mean. Okay. Here we are giving one example. Let us see what that example is. Scooter, a scooter. There are two fellows having two scooters. One fellow scooter gives 40 kilometers per liter. Another fellow gives 30 kilometers per liter. Two different problems. Each one of them travels 120 kilometers. Each one of them travels 120 kilometers. Okay. Well, that means the rates apply. 30 kilometers per liter formula. Okay. Whenever there are rates, better to take what? Harmonic mean, not arithmetic mean. Okay. Rates வரும்போது எடுத்துக்கணும். Kilometers per liter, kilometers per hour, அதெல்லாம் வந்து harmonic mean. அதனால இதுல வந்து harmonic mean கண்டுபிடிக்கணும்னு அர்த்தம். Okay. So harmonic mean வந்து n divided by 1 by x1 plus 1 by x2. இது ரெண்டு தான் இருக்குது இந்த இடத்துல. N is equal to 2 here. Okay, this becomes 2. 1 by x1, 1 by 40. Then 1 by 30. Okay, 1 by 40 and 1 by 30 by 2. இங்க வந்து 120 இல்ல 60 கூட எடுத்துக்கலாம். இல்ல 120 எடுத்துக்கலாம். இது into 4 into 4. இங்க 4 வருது. இது into 3 into 3. இங்க 3 வருது. Divided by. So, 2 divided by 7 by 120. You are getting that. That means 2 divided by 7 into 120. That is equal to 240 by 7. Okay, 240 by 7. So it will go 3 times, 30 it will go 4 times, 34, and the remaining 20 it will go 34.3, 34.28. 34.3. Correct or 34.3 is answer. So that is the first problem, harmonic mean. Now, the petrol consumed by both of them is 2 liters per head. In this case, you are not focusing on 40 kilometers per liter and 30 kilometers per liter. Instead, you are focusing on a fixed number of liters. So, fixed number of quantity. In that case, whenever the quantity is fixed, x1 is fixed, x2 is fixed, and they are not rates like x per meter, kilometer. They are not rates, okay? The 2 liter given. In that case, you go for arithmetic mean. That is the best way to do. When you are doing change in population, which is the mean to take? Geometric progression, because population changes at geometric rates. Okay, so population change and all you have to do. Then per year change, all that changes and all you go for geometric mean. Rates and all you go for harmonic mean. Simple values are given. No rates are given. And no changes over the years are given, then you go for arithmetic mean. You understand?
Yeah, uncle. I don't know. I was on mute.
Because you have to understand that in order to decide which method of whether arithmetic mean or geometric mean or harmonic mean, which one you should use where. Okay, so you have to make that decision yourself only. So when you are making that decision, normal point value numbers are given, arithmetic mean you go for. Rates are given like kilometers per liter, kilometers per hour, or periods per semester, like that, and all some rates are given. Go for harmonic mean. Geometric mean is given when you are calculating population across every 10 years, or every year the growth in exports are given, or something like that. In that case and all, you go for geometric mean. Okay, that is what you should do. Now let us do the second part. The second part is arithmetic mean. This one you have to calculate geometric mean. This one you have to calculate arithmetic mean. So, what you have to do? Total distance covered. Very simple. Total distance covered. First fellow covers 40 in 2 liters. Second fellow covers 30 in 2 liters. Both of them using 2 liters. Then total number of liters used is 4. Okay. So that means 80 plus 60 divided by 4. 140 divided by 4. That is equal to 35. Yes, and there is an arithmetic mean will always be greater than harmonic mean. That's why we saw that when we calculated harmonic mean, it came 34.3. When you are calculating arithmetic mean, it should come greater. It's 35. Okay. So that is the calculation. So why this example 8.14? For you to differentiate where to use harmonic mean and where to use arithmetic mean. All right. Okay. Now let us go to example 8.15. Are you able to see?
Yeah, uncle, I am.
Okay, then let us keep this like that. Example 8.15.
Sure.
Okay. Person purchases tomatoes from each of the 4 places at the rate of one. See, at the rate of at the rate of குத்துட்டாலே என்ன கண்டுபிடிக்கலாம்? Harmonic mean தான் கண்டுபிடிக்கணும். ரைட்டா? வந்துச்சு. 1 kg per rupee. One fellow is giving 1 kg per rupee. Another fellow 2 kg per rupee. Another fellow 3 kg per rupee. Another 4 kg per rupee. Okay. So here you find the simple way. N divided by sigma I by x of I. I is equal to 1 to n. So n is equal to 4 here. Okay. Therefore 4 divided by 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Okay. That's what is given. Now here you have to take 3 into 4, 12, 12 as the denominator. Okay, this will be 12. This will be 6. This will be 4, this will be 3. 12 plus 6, 18. 18 plus 4, 18, 19, 20, 22. 22 plus 3, 25. So 25 by 12. 4 divided by 25 by 12. Instead of that, what you have to do? 4 by 25 into 12. Okay, 4 into 12, 48. 48 by 25. 48 by 25 is equal to 1.92 kg per rupee. You got it? Very simple.
Yeah.
Harmonic mean, your calculation. Okay.
Hmm.
How to calculate harmonic mean? When to apply harmonic mean? Whenever at the rate of is given. Somebody is coming 40 kilometers per liter or 1 kg per rupees. Whenever rates come, first choice you must go for harmonic mean. Whenever changes across the years come, first choice go for geometric mean. Whenever no rates are coming, no changes are coming, only raw data is given. Okay, fixed data are given and point data x1, x2, x3 like that is given. Then you go for arithmetic mean. That is the whole thing. Now we have finished one important thing. What we have finished? We have finished arithmetic mean, geometric mean, harmonic mean, which are all measures of central tendency. We have also finished quartile, deciles, and percentiles, which are also measures of central tendency. But these are positional measures. Which one? Quartile, decile, and percentile are positional measures of central tendency because they are like the median. Okay, right at the center, or right at the quarter, or right as 3/4, or right at 1/10 or 2/10 or 3/10 or 4/10 place, like that, or right at 100 or 200 or 300 or 400 or 99 by 100th place, like that. So place based, position based, those are measures of central tendency, which is called as quartile, decile, and percentile. That is what we did first. Next, we did other measures of central tendency, which is mean. 3 types of mean we have done: arithmetic mean, geometric mean, and harmonic mean. Over. Now we are going to go for the opposite. Okay. Why we are going to go for the opposite? Because measure of central tendency alone is not enough to give the correct characteristics or picture of the data. We need another information. We need another information, which is the opposite of measure of central tendency. Measure of central tendency is like this. Okay. Let us say 3, 5, 9, 11. They are all tending towards the center, which is 7. Okay. That is why it's called measure of central tendency. 3 and 5 are going towards above. 9 and 11 are going towards below. Negative. This is positive. Okay, but they are all moving towards 7, which is the central tendency. That is the idea of central tendency. Okay, you got it. Now let us go for dispersion. Why measures of dispersion? Because now consider the series. The series you consider. 7, 8, 9, 10, 11 is there. 7, 8, 9, 10, 11 is there. Then 3, 6, 9, 12, 15 is also there. Then 1, 5, 9, 13, 17 also there. Okay. In all this, what is the arithmetic mean? It is always 9. Okay. But look at the range here. Range is 11 minus 7. Range is 4. That means this data is very homogeneous, very near to each other. Very close to each other. Okay. It is not scattered. You understand? But consider this one. This range is 17 minus 1. Range is 16. So this range is 16. That range is only 4. That means it is very much more scattered, which means it is more heterogeneous. The data is varying widely. Okay. Heterogeneous na enna parthom? Varying widely. Okay, that is the meaning of heterogeneous. The data is varying widely. That is the meaning of heterogeneous. Okay. So same average is coming. Same n is also equal to 5. See, that is the beauty of it. Okay. Mean is also equal to 9. Arithmetic mean equal to 9. N is also equal to 5. So you will think that all the N is also 5, arithmetic mean also 9. That means all the three must be the same number series, but they are not the same number series. They are different number series completely. Okay, so how to find out now? They are different or not? Okay, to get the idea that these three are different. One is very homogeneous, one is extremely heterogeneous, one is in between homogeneous, heterogeneous. For that only you have the measure of dispersion. Dispersion means again scattering. Disperse ஆயிடுச்சுன்னா என்ன ஆயிடுச்சு? குரூப் டிஸ்பர்ஸ் அப்படின்னா என்ன அர்த்தம்? எல்லாம் அவங்கவுங்க இடத்துக்கு போங்கடா, எல்லாம் வீட்டுக்கு போங்கடா அப்படின்னு அர்த்தம். இல்ல, ஒரே இடத்துல கூடி நின்றாங்க. Dispersena all go to different places. Scatter away. Okay, that is a measure of dispersion. So that is what we are going to now see from now onwards. Okay, the reverse of what we have seen so far. Two types of measures of dispersion we are going to see. Okay, one is measures which express the spread of observation. See, the spread means dispersion. The spread of observations in terms of the distance between the values of the selected observations. Okay, இதுக்கு 5, 7, 9, 11, 15 இருக்குதுன்னா இது 2, இது 4, இது 4, இது 2. ஓகே, இந்த மாதிரி இந்த வேல்யூஸ் எங்க இருக்குது? The distance between the values of selected observations. When you do like that, you called this deviation, measure of deviation is called, okay, one type of deviation. For example, range is this type of deviation. Then interquartile range is called quartile deviation. This is one type of deviation. There is another type of deviation where you find whether the spread of observations in terms of the average of the deviations or observations from central value. In this case, you will take arithmetic mean or something, and from arithmetic mean, how much each value is distance. X, x1, x2, x3, like that, x4, like that difference, of the values from the average mean. Okay, that is called mean deviation, and there is another thing called standard deviation. We will not do standard deviation, we will do mean deviation. Okay, this one we will do quartile deviation this time. Quartile deviation this time we will do mean deviation. Ida pantu in class munjichu. Okay, correct. We are half an hour, we can finish half an hour. Half an hour. 4:45 we can finish. Okay, no problem. Next class we will start the exercises, and you can do one exercise today. We will do one exercise today, and you do one exercise as homework and come. Then remaining 13 problems we will do on Tuesday. I will do 6 problems. You can do 6 problems. We can finish it. Homework has 6 problems. We can finish it. Okay.
I don't think so. I can finish that big of a homework, uncle.
Homework now only 2 exercises, man. Entire chapter.
Okay.
There is only 1.1 exercise, and there is only 8.1 exercise and 8.2 exercise. 8.1 is for covering everything in statistics, and 8.2 is covering everything in probability. So after today's lesson, we will have only one exercise. Of course, 15 problems are there, but still everything is covered, and we just have to do the exercises. We'll try to do 6 problems in class. You do 6 problems as homework. We'll finish it off.
Sure.
Okay, what is quartile deviation? Very simple. The simplest thing. Okay, quartile deviation. You know how to find Q1. You know how to find Q3. Correct. Data la idu Q1, idu Q3, idu Q2. Okay, Q3 minus Q1 by 2. Idan formula. Idu kandupuchina idan quartile deviation. QD. It's called QD. Quartile deviation. Okay. Q3 minus Q1 by 2. That's all quartile deviation. Now, this is an absolute value. When you given a set of data, in order to find if you find the quartile deviation, it applies only to that set of data. Okay. Now, why we want to do this quartile deviation? We want to compare one set of data with another set of data. For example, what I told you, okay, 5, 6, 7, 8, 9. This data with 1, 3, 5, 7, 9, 11. Okay, 13. Or 5, 7, 9, 11, 13. Or 1, 3, 1, 5, 9, 13, 15. See, this group of data, this group of data, this group of data. So 3 sets of data, data 1, data 2, data 3, we want to compare. When you want to compare, you cannot use the absolute value, QD. Quartile deviation is only an absolute value. You need a relative value. You need what? A relative value. From this you get one relative value, this you get one relative value, this you get relative. That is called coefficient of quartile deviation.
Okay, so 5 is a relative value, uncle.
Huh?
5 is a relative value, uncle.
No, formulas there, very simple. You find quartile deviation, no, Q3 by Q1. Instead of dividing it by 2, what you have to do? What you have to do? You have to divide it by Q3 plus Q1. That's all. See, if you divide Q3 minus Q1 by 2, you get QD, which is an absolute value. It's absolute. If you want to find the relative value where you want to compare different sets of data, then you use Q3 minus Q1 by Q3 plus Q1. Okay. Once you get this value for one data set, another data set, third data set, you can compare the things and you find the quartile deviation. Okay. If the quartile deviation is large, then you know that the dispersion is large, which means that there is more scattering, that the group is more heterogeneous. If the quartile deviation, coefficient of quartile deviation is very small, then you can understand that for the same kind of data, the numbers are coming very close together. Okay, that you can find out. So even if the mean is 9 for all the 3 data and n is 5 for all the 3 data, the coefficient of quartile data, the coefficient of QD, that value will show that the data is spread more for the third series. Data is less spread for the second series. And data is very closely held for the first series, which means it is homogeneous. Okay. Homogeneous and heterogeneous, that you also have to remember. Heterogeneous means very much scattered. Homogeneous means all sticking together, very close together. Okay. Now let us go and compute this quartile deviation and we will have an example. Very simple quartile deviation. Okay. Now here you have one series. The null number 1, 2, 3, 4, 5, 6. This is X. Then number of, no, this is not X. Marks is 20, 28, 40, 12, 30, 15, 20. This only is X. This is not needed at all. Okay. 1, 2, 3, 4, 5, 6, 7. N is equal to 7. That's all you need for that. Okay. Now, what is Q1? Q1 is equal to 1 into 7 plus 1 by 4th value. Correct? Remember, first time we saw that. Okay. So, 8 by 4th value. That is equal to second value. Second value is what? 15. So, Q1 is equal to 15. You already know. You know how to find that. This find out the same thing. Then you have to find out Q3. Q3 is equal to 3 by 4th into n plus 1th value. Okay. N is 7, n plus 1 is 8 by 4, 3 into 8 by 4. Equal to 6th value. Okay. What is 6th value? 1, 2, 3, 4, 5, 6. 6th value is 40. So Q3 is equal to 40. Q1 is equal to 15. Q3 is equal to 40. The answer is QD is equal to quartile deviation equal to 40 minus 15 by 2. How much? 15, 25, 35. That is 25 by 2. That is equal to 12.5. That's all. QD. Nah, nothing. Very simple way to find out QD. Okay. Now, you want to find out coefficient of QD. Coefficient of QD is equal to, don't divide by 2. Just keep the 25 on top. Now, you do Q3 plus Q1. 15 plus 40. How much? 55. 25 by 55 divided by 5, 5 by 11. So it is 5 by 11. Calculator, you do 5 by 11. How much it is coming? 5 divided by 11. 0.45 is the answer. 5 divided by 11 is equal to 0.45. So that is the coefficient of quartile division, QD. Okay. Now, for different series, if you calculate this one and you find out that 0.45 is greater than 0.35, okay, another series is giving 0.35, then what is the meaning of that? The meaning of that is 0.35 quartile deviation coefficient is the numbers are sticking closer together. Okay. 0.45 quartile deviation, numbers are more scattered together. That is the idea. You understand? இது என்னடா அர்த்தம் என்னமோ QD கண்டுபிடிச்சு சொல்றாங்க கோஎஃபிஷியன்ட் ஆஃப் QDன்றாங்க என்னடா இதுனா இதான் அர்த்தம் இதுக்கு how closely packed they are. Smaller the value, the more closely packed. How much higher the value is, the more the scattering. Okay. Right. 0.455. Okay, no big deal. Let us do example 8.17 now. Compute the coefficient of quartile deviation from the following data. Now, what is given is marks are given and frequency are given. X is given, F is given. Okay. So, what you have to do in this case, you have to find the cumulative frequency. You have to find cumulative frequency. X and F. So, 10, 4 in the data, it will tabular. Horizontal, vertical, இது already given. Okay. Now you find cumulative frequency. 4 plus 7, 11. 11 plus 15, 26. 26 plus 8, 34. 34 plus 7, 41. 41 plus 2, 43. So sigma F is 43. Okay. Now that means N. N is 43. Now you have to find out Q1. What is Q1? Q1 is equal to 1 into N plus 1 value by 4. That is 43 plus 1 by 4. That is 44 by 4. That is equal to 11th value. Now you go inside this, find where is 11. 11 only in the between 4 and 11 irukku. Apana the actual value is 20. So Q1 is equal to 20. Okay. This you already found out how to find Q1 for data with frequency distribution, point data with frequency distribution. Same method you have to adapt here. Okay. Only thing now you are doing it for finding out the quartile deviation. There you just found out Q1, Q3 for its own sake. Then what you have to find out? You have to find out Q3. Q3 will also be equal to, let us say, 3 into 43 plus 1 by 4 value. Okay. 44 by 4. 3 into 44 by 4. 11. That is 33rd value. So what is 33rd value? Again, go and find. In the range. In the range, value. Marks is 40. Okay, so Q3 is equal to 40. So what is the formula for QD? Q3 minus Q1 by 2. That means 40 minus 20 by 2. That is 20 by 2. That is equal to 10. Okay. So QD is equal to how much? QD is equal to 10. Then you can also find out if QD is 10, 40 minus 20 by 2, then 40 minus 20 by 2C is equal to 10. Then you can also find out coefficient of QD. 40 minus 20 by 40 plus 20. Okay. Q3 minus Q1 by Q3 plus Q1. That's all there is. This becomes 60. 10 by 60. Sorry, 20 by 60. 20 by 60. Q3 minus 10. So 20 by 60 is 0.3. 1/3 is equal to 0.333. How many 3 you want to add? That is up to you. Okay. That's all very simple. You understood this one?
Yeah, kind of, uncle. Yeah.
Very simple. Now let us go for quartile deviation of continuous data. திருப்பி இதுல தான் சுத்தி நிற்கும் ஸ்டாட்டிஸ்டிக்ஸ். ஒன்னும் புதுசு கிடையாது. Discrete point data, discrete data with frequency, and then continuous data with no with frequency. Okay, there will be no point data. In this case, we have to use the formula. Okay, usually we will find the midpoint. Okay, in this case we have to use the formula. What is the formula? Example 1.18. So horizontal data, first you put as vertical data. So you have 10 to 20, 12. You put that here like that. 20 to 30, 19, 30 to 40, frequency is 5, all of that. Okay. Keep calculating the cumulative frequency. 12 plus 19, 31. 31 plus 5, 36. 36 plus 10, 46. 46 plus 9, 55. 55 plus 6, 61. 61 plus 6, 67. Finally, you get n is equal to 67, sigma f. Okay, n is equal to 67. Now, what you have to find, Q1 is equal to n plus 1th value by 4. Okay, that is 67 plus 1 by 4. 68 by 4. No, 60. No. Only for continuous data, you should not use n plus 1. Remember, I told you already. I myself forgot. Only for continuous data, you should not use n plus 1. You should directly use n by 4. Okay, so it becomes 67 by 4. That is 16.75. Okay, 4 will go in 67, 64, 3/4 is remaining. So 16.75. Okay, so 16.75th value rounded off will be 17th value. Where is 17th value? It is in this range. Okay, now what you have to use in this range, you have to go and use this value as L, this value as F, this value as PCF, previous cumulative frequency 12, and class value is 10 to 20. 20 minus 10 is 10. So C is equal to 10. Okay, now you have to use the formula. Q1 is equal to L plus n by 4 minus previous cumulative frequency by current frequency into class value. So n by 4 you've already found out. N by 4 is 16.75. All right.
Yeah, uncle.
This is 16.75. So 16.75 minus PCF, that is minus 12. Okay, into 10, this is class value into 10. Current value is 9 divided by 9. So L 20. L is 20. 20 plus this thing. That is a formula. Once you use the formula, it's straightforward to calculate. Straightforward to calculate. Okay. Then 16.75 minus 1 second. Sorry, I just closed the door. So 16.75 minus 12 is 4.75. 4.75 divided by 19 will be 2.5. So 20 plus 2.5 or into 10. Okay, 0.25. 0.25 into 10 is 2.5. So 20 plus 2.5 is equal to 22.5. That's what you're getting here. 22.5. That's Q1. Q3 ல என்ன பண்ணோம் வந்து 3 into 67 by 4. So 67 into 3 is 21, 18, 19, 20, 201. 201 by 4. அதில் 20ல 5 times போகுது 50ல 0.25. Okay, 50.25. This is correct. So find 50.25 where it is there in the 50.25 is there in this place, in this range. Okay, so L will be 50, F will be 9, PCF will be 46, class remains 10. Okay, now you have to do 50 plus what is 3 by 4th? You already got that. 50.25. 50.25 3 by 4th by 9 into 10. Okay, that's what he has done. Okay, 50.25. Sorry, minus PCF we forgot. Minus PCF. Okay, PCF was 46. 50.25 minus PCF by n into 10. Okay, so that will be some 4.25 by 9 into 10. 4.25 you can calculate, it will get 4.72. So 50 plus 4.72 is 54.72. So you got Q3 value. Now what you have to find? Q3 minus Q1 divided by 2. That is nothing but 54.72 minus 22.50. 2, 2, 2, 3, 32.22 by 2, 16.11. This is the answer. QD is equal to quartile deviant is equal to 16.11. Okay, let us see whether textbook is agreeing with this 16.11. Yes, it's agreeing 16.11. Very simple. Okay, that's all for cumulative continuous data. For continuous data, you have to use that complex formula. Okay, it is not complex formula. Very simple. L plus this portion alone will vary. I told you, no, this portion alone will keep varying. Okay, it will be, if it is Q1, then it will be n by 4. It is Q3, this will be 3n by 4. If it is D7, it will be 7n by 10. If it is P36, it will be 36 by 100 into n. Okay, that will alone keep varying. That's all. Okay, now we finish quartile deviation. Let us go on to mean deviation, and with that we will finish our class today. Okay. Mean deviation. I don't know whether you'll be able to work out all the examples because we only have 10 minutes. Let us see. Mean deviation, I told you, it is not positional. Quartile deviation is positional. Mean deviation is about an average. It's about the mean. You have found the arithmetic mean, then each of these value x1, x2 is at a distance from x3 is at a further distance. The x4 is even further distance. X5 is very close by. Okay. Now what you have to do? Constantly subtract from x the average and do the sigma of that. Okay. And then divide it by n, number of values. That's all is mean deviation. You already know arithmetic mean, you know how to find out. That is the same formula that is given here. So don't think he has given anything new. Old one is coming in new form. Sigma x minus x bar is mean deviation by n. Okay, that is sigma d by n. The d means deviation. Deviation is x minus x bar, x minus arithmetic mean, and n is the number of observations. This is the simplest formula for direct one. Now, you don't need to do only for mean. They will ask you the same mean deviation for using median. What do you do using median? Then you arrange everything in ascending order. Okay. For mean, you don't have to arrange in ascending order. You can just put the table, put the values of x, then find out the mean, which is x bar, and then you x minus x bar. You put out the tables, and then just find sigma x minus x bar. Okay. Then total number of x is n. Then you divide this by this, you will get arithmetic mean. That is all very easy. But for median, you have to, these values have to be arranged in ascending order. Okay, arrange them in ascending order, and then x minus median for each. Instead of x minus x bar, x minus median for each, and divided by n, same formula. Okay, only thing where you are finding x bar, instead of that, find median. And x minus median you do, instead of x minus x bar. And both you divide by n. This also you divide by n, that also you divide by n. Okay. Now, very important thing, you must take only the the positive value. Okay, only the quantity. Okay. Plus or minus ignore panninga. Only the raw value or the quantity you have to take. Okay. What do you call that? It's not coming to my memory now. Absolute value. Take only the absolute value. Don't take plus or minus signal. Okay. Okay. Now for a discrete series, how will you calculate mean deviation? This is the formula, okay, for when the data is given as point data. Suppose data is given as with frequency, what you have to do, you have to take additional one more column. You have to find first mean, then you have to find take x, then f, okay. Then from that you have to do x minus x bar. And then one more column you have to do is this is become d, okay. You have to do fd. Fd means this into this, okay, and find sigma fd and then divided by sigma f. Sigma f is n, okay. இதனுடைய sum, frequency உடைய sum லாம் எடுத்தீங்கன்னா n is equal to sigma f is equal to whatever, let us say 35 or whatever is coming. Okay, இதுலயே all the sigma fd you have to take. Okay, that is the way to do for discrete data with frequency it is coming. Okay, now what if discrete data is not coming? What if it's continuous data? Only these three types will keep repeating. I told you, no. திருப்பி மூணே வடை தான் சுட்டு நிக்கிறோம். திருப்பி மூணே வடை தான் திருப்பி சுடணும். அது change in formula, சின்னதா formula will keep changing. Okay, once you come to continuous series, you should not do n plus 1. Remember, for finding quartile, percentile and decile, when you come to continuous series, you should not use n plus 1. You should only use n by. Okay, very important. Now here is continuous series. How to calculate mean deviation? You don't have x value. You won't be given x value. What instead you will be given? You will be only given the classes 0 to 10. அதனுடைய frequency இது கிளாஸ் கொடுத்துருவாங்க. அதனுடைய frequency கொடுத்துருவாங்க. இது வந்து 10 வருது, இது 5 வருது, 20 to 30 ல 10 வருது, 40 to 50 ல 5 வருது. இப்படிதானே கொடுப்பான். இதுதான் continuous data. This is the meaning of continuous data. Okay, in this case what you have to find? You have to find midpoint. Instead of x, you find midpoint. Class 0 to 10 midpoint is 5. 5 will become your x, or you just keep it as m. Okay. So deviation you have to find. Okay, first everywhere, no, wherever you are completing mean deviation, you have to find arithmetic mean first, or you have to find median first, whichever they ask. Either this or this. First you have to find. This is the first step. Find arithmetic mean or find median, first step. Then you form that table. Once you form the table, you already form the table and then find arithmetic mean first. Okay, from there you have to find the sigma of f into m. The class உடைய mid value இப்படி போட்டியா, இது 5, 20 to 30 வந்து 25, 40 to 50 வந்து 45. இதான் mid value. Okay, this m into f you have to find another column, m into f. m into f ஒரு column போடு, or let me put it this way. You want to find that, then you do f into d. Okay, d here will be nothing but, instead of x minus x bar, it will be m minus x bar, mid value minus x bar. That will be deviation. So sigma fd again by n, that is your mean deviation. Mean deviation is that only. Okay, now these are all absolute values. How to find relative measures? Just like on the qd was an absolute value. You cannot use it to compare two different data sets. Two different data sets you cannot compare using qd. What you did? You did coefficient of qd. Then you can compare two different values. Either 0.5 coefficient or 0.3 coefficient. Then 0.5 coefficient has got a greater scattering, more dispersion, and it is more spread out or scattered out. அப்படின்னு கண்டுபிடிக்கலாம். அதே மாதிரி relative measure for mean deviation. இது வந்து mean deviation வந்து absolute measure. Relative measure எப்படி கண்டுபிடிக்கிறது? Okay, very simple here. Okay, very simple. There you did q1 plus minus q3 minus q1, sorry, q3 minus q1 by q3 plus q1. இங்க என்ன பண்ணோம்? mean deviation value of find பண்ணிட்டு divided by mean. That's all. Already you know mean. Only very simple step. Okay. Or divided by median. Mean deviation கண்டுபிடிச்சிட்டு divided by median. Depending on which one they are asking. Okay. They may ask use median or use mean. Depending on that. Okay. Very simple. Say 45 ஆயிடுச்சு. Correct ஆயிடுச்சு time. We will not be able to do one sum also. Okay.
Yeah.
Why don't you do first sum for homework and come?
Okay.
Very easy. You do first sum for homework and come. So mean deviation about mean deviation divided by mean, or mean deviation about median divided by median. அவ்வளவுதான் விஷயம். இது கொடுத்துட்டா முடிஞ்சு போச்சாங்க. இந்த எக்ஸாம்பிள் மாத்திரம் பார்த்துடலாம்பா. Calculate the mean deviation about mean and its coefficient of the income groups of 5. இது வந்து point data. இது வந்து point data 1 2 3 4 5 n is equal to 5. Okay, this is each x1 x2 x3 x5. Okay, very simple. You have to find out, add up all this, and you add up all this, you get 22,000. Okay, divided by 5 4,400. இதுதான் mean. First step என்ன பண்ணனும் நம்ம எப்போ சொன்னோம், when you are finding mean deviation, you first find mean. X bar முதல்ல find பண்ணிட்டு அதுக்கு அப்புறம் you write down x. Okay, then you find x minus x bar, that is d. இதுதான் அந்த column, x minus x bar. Okay, here 4,400 is the mean. Okay, 4,000 minus 4,400 is equal to 400. Why? I told you, you must not include the positive or negative aspect. Only the absolute value you must put. Okay. That is why you are giving 400, not minus 400. Otherwise, it would have been minus 400. But it's not minus 400, it's 400. Okay, then 4,200 minus 4,400. That is equal to 200. 4,400 minus 4,400 is 0. 4,600 minus 4,400 is 200. 4,800 minus 4,400 is 400. Okay, now add all this. Once you add all this you don't need to do. Sigma x don't need. All you need is n. N is how much? 1 2 3 4 5 already. N is equal to 5. Then you add up all this, 400 plus 200 600 plus 200 800 1200. Very good. Sigma d is 1200 divided by 5. Okay, 1200 divided by 5 is equal to 240. அவ்வளவுதான் விஷயம். இங்க 240 இருக்குதா? ஆமா, 240 வந்துச்சு. Coefficient of mean deviation எப்படி? Already you know 240. So 240 is already the mean deviation. What you have to divide it by? You have to divide it by mean. Okay, mean was 4,400. So what you have to do is 240 must be divided by 4,400. இது cash ஆகும். 24 12, இது வந்து 220, இது வந்து 6, இது 110, again by 3, இது 55. So 3 by 55 is 0.055. Okay, we calculate. That is the answer. We are not able to do example 8.2. 3 minutes here. So do sum number 1.
Okay.
Exercise, because it doesn't depend on learning all this.
Yeah. Okay.
Okay. All these examples we'll do later. Exercise 8.1, do first sum.
Okay.
You can also do second sum. Do sum 1 and sum 2. Exercise 8.1 and 1.
Okay, uncle.
Okay, wow.
Okay.
Remember that. Homework.
Yeah, sure.
Exercise 8.1.
8.1, first and second sum. Okay.
Exercise 8.1. I'm just putting it. 1,2. Homework. Very easy. Then we'll see the remaining sums. Okay, man. Very nice.
Okay.
Bye-bye then. See you.
Sure, uncle. Bye, uncle. Have a nice time.
Yeah, have a great evening. Have a great weekend. Bye-bye.